Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize patterns in linear functions and exponential functions, and how to recognize the differences between linear functions and exponential functions. How are we learning it? Through the Comparing Linear and Exponential Functions Part 2 notes and the Comparing Linear and Exponential Functions Part 2 assignment. When can we use this information? To examine sales trends at work to determine how much growth is occurring within the company sales. How do we know we learned it? By getting a score of 4 on the Comparing Linear and Exponential Functions Part 2 assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. Next, we'll do our weekly raffle. After that, we'll go over the Comparing Linear and Exponential Functions Part 2 notes. And then I'll give you time to complete the Comparing Linear and Exponential Functions Part 2 assignment, which is on Desmos. Once you've completed the assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over the learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Exponential Function Study Guide and any incomplete assignments that you may have. Let's take a look now at the Comparing Linear and Exponential Functions Part 2 notes. The notes begin with the learning goals and success criteria. Now, first of all, what is a linear function? A linear function occurs when the graph of a relation set forms a straight line. So when we plot the points, if it forms a straight line like this, that means it is a linear function. Now, what does a linear function look like as a table? Well, if we look at the table here, the rule is if all of these in each column, so this column and this column, if the change is all consistent and it's addition, then we say that the set is linear. So for instance, we have 1, 2, 3, 4. So we can see that it is consistent, there is a consistent pattern, and the pattern is that we're adding by 1. So that's addition. So now if we look at this side, we have 2, 4, 6, 8. Again, consistent pattern, addition by 2. So, is there a steady change in the number of months? Yes, we're changing by 1 month each time. Is there a steady change in the amount of rainfall? Yes, there is. We're changing by 2 each time. So therefore, we could say, yes, this set is linear. And if we were to graph it, it would look something like this and form a straight line. So that's a linear function based on a table. Now from graphs, again, the rule is they form a straight line. So this is an example of a linear function. This is also an example of a linear function. As is this one. It can go up or down. It can be really steep or really flat. This is another example. Again, really flat and going downward. This one's steep and going downward. So all of these form what we call linear functions. Now, how can we recognize linear functions as an equation? Well, it should be able to form y equals mx plus b. Or it could be f of x equals mx plus b. An example of this would be y equals 1/2 x minus 3. This would be an example of a linear function. Notice the powers for both y and x are 1. Now what is an exponential function? An exponential function is a function that forms a curved line that has a line that it will never cross. For instance, this is an exponential function. It's a curved line, it's a single curve, it starts low and works its way up. It could go this direction also, start high and work down. But it has a line it never crosses. Notice this line gets really flat here at the x-axis. It will never cross the x-axis. So there's a line here that forms that it'll never cross. In this direction, it'll keep going and going and going and get really steep. How can we recognize exponential functions from a table? Well, first of all, the rule is the number of months, my x values, should be changing by a consistent amount, and it should be addition. And my y values should be changing by multiplication. So in this case, we have the months. So this is 1, 2, 3, 4. Well, is there a steady change in the number of months? Yes, there is, and it's changing by 1 month each time. Now here we have 2, 4, 8, 16. There is a steady change, and it is multiplication. We're multiplying by 2 each time. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So we're seeing a steady change, and it's multiplication. It is doubling, or multiplying by 2 each month. So therefore, is this exponential? Yes, it is. And if we were to plot these points, it would look something like this and form this curve. Now, what do exponential functions look like as graphs? They always form a curve, a single curve. So, for instance, this is an exponential function. This, even if I shift it over, it's still considered an exponential function. If I have it go downward, that's an exponential function. And if I have it go below the x-axis, still an exponential function. All of these are examples of exponential functions. Now, exponential functions are of the form y equals a to the x times b. Or it could be f of x equals a to the x times b. Here, an example of this is y equals 3 to the x times 4. Now, if you notice in all of these, y has a power of 1, and x is the power of the base number. So these are exponential functions. So how can we compare these? So the question says, based on the table below, does each table represent a linear function, exponential function, or neither? Well, if we look at this one, we have 1, 2, 3, 4, 5. So this one's consistent and going up by 1. So it could be either linear or exponential at this point. Then we have 3, 6, 12, 24, 48. Well, 3 plus 3 is 6. 6 plus 3 is not 12, so it's not linear. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So that means it's got to be exponential. Now this one, 2, 4, 6, 8, 10. So we do have a consistent pattern. We are adding by 2. So it could be either linear or exponential. Then we have 1, 2, 3, 4, 5. Well, 1 plus 1 is 2, plus 1 is 3, plus 1 is 4, plus 1 is 5. So they're both consistent, they're both addition, therefore it's got to be linear. Now this one says negative 2, negative 1, 0, 1, 2. So again, we're adding by 1 each time, so it could be either linear or exponential at this point. Then we go 8, 4, 0, 4, 8. So here we subtracted 4, then we added 4, So it's not a consistent pattern, so therefore it's neither linear nor exponential. Now we have our graphs. We're supposed to determine whether it's linear, exponential, or neither. Well, this first one does have a curve, but it curves in both directions, which we know that exponentials only curve in one direction, so therefore this is neither linear nor exponential. Then this one, we have a straight line. Well, we know a straight line forms a linear function, so that one is linear. This one has a single curve, so that one is exponential. Now, looking at the equations, we have y equals 2/3 x minus 4. Well, both of them have a power of 1, and we have both the x and y, so that one we said was linear. It also looks like y equals mx plus b, so we know it's linear. Now this one is y equals 2/3 times negative 4 to the x power. Well, we should notice that looks like b times a to the x, which is exponential. So this one is an exponential function. This one says y equals 2/3 times the absolute value of x minus 4. Again, it looks similar to this one. We have x to the first power and y to the first power, but the absolute value changes things, so it is neither linear nor exponential. Let's talk now about how to sign in to Desmos to complete your work. So what we're going to do is you're going to click on the link to go to the assignment, and it should take you to a page that looks kind of like this. And right here where it says sign in with Google, we're going to click there. And it's going to pop up with our email accounts. You're going to click on your school email account, and it should already have you logged in because you should have already been logged in using Google Classroom. From there, I'm just going to click start the activity, and it will take me into the assignment and allow me to begin. So that's how you will log in to Desmos using Google. Let's take a look now at the comparing linear and exponential functions part 2 assignment. Our assignment begins with our learning goals and success criteria. If we scroll down, there's a link here to take us to the Desmos activity. We'll go ahead and click on that link, and it takes us to a page that looks like this. We'll go ahead and click start the activity. The activity begins with our learning goals and success criteria. We'll go ahead and click next. Now, for this one, it's telling me that it's linear. and I'm going to complete the table for the linear function. So we know that in order for it to be linear, we have to have a consistent change of addition in the x's and a consistent change of addition in the y's. So let's go ahead and do that. So we have a consistent change in the x's, right? We're adding by 2 each time. And we need to have a consistent change in the y's as well. So we're adding by 3 here, so we need to keep adding by 3. So 7 plus 3 is 10. 10 plus 3 is 13. 13 plus 3 is 16. Then we're going to go ahead and enter our parent function. Well, we should know that the parent function for a linear function is y equals mx plus b. And now we're going to go ahead and sketch a graph of a linear function. It can be any linear function, so I'm going to go ahead and use the line tool. I'm just going to start here and just draw a straight line. Just like that. So that would be a linear function. Then we'll click next, and we're going to do an exponential function. Now for an exponential function, our parent function should be y equals a times b to the x. And in this case, we should have a consistent change of addition in the x's and multiplication in the y's. So we would multiply by 2 to get to 8. So then this one would be 8 times 2, and then times 2 again, and times 2 again. So you'll fill that in. And then we'll sketch a graph. So for this one, it should look something like this. So that would be the graph of an exponential function. And then we'll click next. It gives us our tables that we created, and we're going to state how they are different. Well, we already mentioned it. The x's should have a consistent change of addition, and with linear, the y's should also have a consistent change of addition, whereas with exponentials, they should have a consistent change of multiplication. And then here, we can see our two graphs and what they look like, and we're going to state how those graphs are different. So you'll just state how they're different, and then click next, and then we'll state how the equations are different. So you'll state each of those things, and then that should complete the activity. Once you're done with the assignment, you'll go back to your Google form and click next. This will take you to your before you go. Go ahead and fill out your before you go and then submit your work on Google Classroom.